Good morning, ladies and gentlemen. Welcome to today's little overview of the Ready, Set, Go for Unit 1, Lesson 5. Let's dive in here. So on each of these beginning ones, you need to indicate on the table where you see the rate of change, so where you see a thing. Also the same thing on the graph. So when I come to a table and I'm trying to figure out rate of change, that is the same thing as slope. And so remember, slope is rise over run. It's just how much the f of n is changing over how much the n is changing. So when I look at that, I just like, what's the gap here between these? All right, it's minusing 2, it's minusing 2. This one here, what's going on here is adding 1, and that means our rate of change is it's going down 2 as it goes right 1. And on the graph here, when I'm trying to figure out my rate of change, again, I'm looking, okay, what's happening here? Looks like it's going down 2 and right 1, which hopefully you realize is the same thing as the previous one. It's going down 2, right 1, down 2, right 1, down 2, right 1. And I just see, you can even draw arrows here, down 2, right 1, down 2, right 1. And that's our rate of change. So that's going on in the first section. In the next section, in the set section here, it's giving you a sequence. You need to write the recursive and explicit function for it. And then you're going to make a graph for that. You have to make sure you label your axes. So let's start with our recursive function. Remember, all recursive functions are going to start with f of n equals f of n minus 1. That means the next term is equal to the previous term. And then what happens to it? Well, I haven't even looked at my sequence yet, and I know how it starts. So you can make sure you just put down what it starts with. And now we can look at what's actually happening here. Well, it goes 2, 4, 8, 16. That's just a process of timesing by 2. And so here I can put times by 2. Often, though, people put that in front. So if you want to put that in front, you do 2 times f of n. But I'll also take it after. It's okay. It works out the same. But this part of the function only tells you the pattern. It doesn't tell you what the first term of the sequence is, which is an important part of it. And so over here, I'm also going to say, well, the first term, which is what f of 1 means, means the first term, is 2. And it's the starting number is 2. Perfect. We got that. So now it's time for the explicit function. Again, we got f of n equals. And when you think about where this starts at, well, it starts with 2. And what is it timesing by? Well, it's timesing by 2. And now we need to put n in our exponent here because it's doing that. It's multiplying by it multiple times. But we do have to account for which term in the sequence this is. This is the first term and the second term going like that. And so my n up here, if I were to plug in 1 here, I would be getting 4 as my answer. F of 1 at this point equals 4, which doesn't match the 2. And so we need to adjust our exponent here and subtract 1. So it goes back a term, so it actually lands on 2 there. So there's my function, f of n equals 2 times 2 to the n minus 1 power. So now I'm going to come over here. These are all just positive numbers, so I'm just going to do my axes this way. These are going to be my steps here, or terms in the sequence. Well, let's do like the first 4, because it's got first 4. So these are my terms in sequence. I just put, sequence number. And then vertically, I need to go all the way up to 16. I think there's probably enough boxes for that. But I'm pretty lazy, and so I'm not going to do that necessarily. Whatever, we'll do it. We'll just count up. 1, 2, 3, 4, 5. I like to label, just the big important ones. 2, 3, 4, 10, 11, 12, 13, 14, 15, and then 16 would be up here. So now I can actually graph all of these. First one's 1 at 2. Next one's 2, 4. Next one's 3, 8. And the last one's 4, 16. It's going to be up here. Okay. By the way, I didn't have to count by ones on something like... Oh, I messed up here. Oh, man, I messed up on both of these. Let me fix that real quick. I didn't go over enough for my 3, 8. There we go. And 4, 16. Okay. On different ones, when you say you start with, on number 6, you start with 300. You don't want to count by ones on your vertical axis here. Maybe you want to count, something like 50s, or you want to count by 25s, because you want to get up to 300 on this one. So you want to count by a different number instead of just ones like I did on the previous one. Let's jump to 8. This one's a little bit different, but it's the same idea. There's a table. Here are the step numbers, and here are the function values. You need to figure out what's going on in the middle to get these numbers here. So let's start with This first one, well, the first one, it just has a 3. It doesn't look like it's doing much with it at that point. But on the next one, well, what did we do with 3 to get 6? And what did we do with 3 to get 12? And what did we do with 3 to get 24? This pattern is just times it by 2. So I'm going to put times 2. And I can put times 2 and times 2 again. We times by 2 a couple times. And on this one, we've times by 2 3 times. Okay, so it's times 2, times 2, times 2. And each of them, you had to times 2 the previous one. So now we can write our recursive and explicit function for it. This is what we've been doing so far on this assignment here. Recursive one always starts with f of n equals f of n minus 1. And again, this one is timesing by 2 again, so you just put times 2. But it does start at a different number, so my first term instead of 2 is going to be 3, because that was the first term of our sequence. On the explicit function, it's very similar. You want to figure out what your starting number was, which was 3, and what's happening to it is timesing by 2. And how many times? We're going to do it n times, but again, when we put in a 1, that would actually give us an answer of 6, so we're actually need to do something to the exponent here to make it match up. We're actually going to subtract 1. That way, if you plug 1 into your function here, the output of this is going to be 3. And so you need to make sure you put the n minus 1 there. So there's that one. And then we got one last one. These ones, make sure you plot the points, draw a little triangle, show the slope. On the last section, you're supposed to get the slope, the y-intercept, and the equation of the line. That's what these are. Slope is m, y-intercept is b, and the equation of the line. As a reminder, a long time ago, last year maybe, you learned what the equation of the line is, which is y equals mx plus b. Well, the m is your slope. Let me put notes in a easier to read location. This is the slope, how it's changing over time, and the b is the y-intercept, or where it hits the y-axis. So we're going to go, let's go to 14 here. Let's find our y-axis first, because that's easier. Your y-axis is here, and it hits it at this point. That number is negative 1. So that's going to be our b. And then the slope, just like we did earlier on number 2 there, we need to find what's the rise and run here. So you find a couple points. Here's 2 points. And now I can figure out what's my change here. It looks like it went down 4 and went right 1. So my slope is negative 4 over 1. So now I can write my equation. Y equals negative 4 over 1 x, not m, x minus 1 or plus negative 1 here. You can simplify that slope a little bit, because negative 4 divided by 1 is just negative 4. So you can do something like that. But I'll take either of them at this point. So there you go, a little overview of how to do things on the Ready, Set, Go for lesson 5.